Yes, hello. I am Kirsten Gram-Hanssen from Aalborg University, and I will talk about uses and practices in heating and ventilating homes. Why do they behave different than we think? And what I will talk about the next 20 minutes is, first of all, that healthy indoor air quality and reduced energy consumption are compulsory. We need to achieve both. And for both goals, the interplay between users, buildings, and technologies is the key. Users, however, are different, and they are also different from what designers think, and we need to understand that. So this is, you could say, my takeaways that I will talk about in the rest of the presentations. When we are designing technology or we are modeling buildings, then we need to anticipate behavior. I think that is something we all know, that this is something we have to do. But quite often that the user behavior turns out to be different from the anticipations that we had when designing buildings. And to show an example of this, I've taken this figure that is based on more than 100,000 detached housing in Denmark to show you how behavior is different from anticipated. So the figures show houses that are energy labeled with A to G labeled, and of course the A labeled houses are those that on paper in the theoretical calculations has the lowest consumption, and the G labeled houses are those with the highest consumption. So the dark bars in the figure show the calculated heating demand of these buildings, and we see that the G labeled houses has very high calculated demand. However, if we look at the light bars, we see that people living in these G labeled houses actually only use around half as much energy for heating the house as the calculation suggests. In the other end, we see that the A-labeled houses, people actually use almost double up of what the calculations say. So somehow there is a mismatch between the calculation, the expected behavior of people in these buildings, and then the way the buildings are actually used. And maybe this is not so difficult to understand if we start to think about how it is to live in these houses. If you live in a very old, inefficient house, then you don't heat all the houses to the highest, all the parts of the houses to the highest temperatures. You wear a sweater when you are inside during winter time, and you wear slippers. So people adjust to the type of house they are living in. And then the other end, we know from a lot of research that people living in new, really well-insulated houses, they also adapt their behavior to the house they live in. So if you live in a very insulated house, you live with higher temperatures and you enjoy the heat, so you walk around barefooted, maybe during winter, and only wearing a simple t-shirt. So people adjust their behavior to the type of building they live in. And this has policy relevance for reducing energy consumption. Because if we think from a policy perspective that energy retrofitting all the G-labeled houses so that they have the same demand as B or C labeled houses, then we might reduce the consumption between the dark bars from the G labeled house to the C or D labeled house. But we can actually not save that much energy. We can only save the energy that is actually used in the G label houses. And we see that this is already at the same level as these much more efficient houses. So we get an explanation here that energy retrofitting buildings do not in real life deliver the energy savings that we really need from a climate perspective. So what is behind this? Is this only a question of maybe poor people living in very inefficient houses? Is this, I would say, primarily a social problem, or what is behind it? This is also a question we have asked ourselves. So the question is if income explain all of these discrepancies. And the figure here I will explain it. It's a bit complicated to understand maybe, but we have taken together what you could call the overconsumption in the ABC labeled houses. So the most efficient houses with a A, B, or C labeled, we have put together what is consumed more than the calculations, and that is shown with the dark bars on top. And then we have also put together the EFG labeled houses and what we could call the underconsumption of the EFG labeled houses, and that is represented by the light bars in the bottom of the figure. And then we have shown this according to 7 different income groups. So what we see is, when we compare this to the income people living in the houses have, and again we have more than 100,000 detached houses in this figure, so we have quite a huge data amount to say these things. And what we see is that in all the efficient ABC labeled houses, we have an overconsumption. We have a higher overconsumption among the richest people living, but we also among the poorest people, those with an income less than 300,000 Danish kroner, they also consume more than the calculation of the energy label would suggest. And similarly, you could say at the bottom, we see that there is a correlation between income and the question of how much underconsumption we have in the poorly insulated houses. But even among the richest people, those earning more than 800,000 Danish crowns a year, they also have an underconsumption. So yes, income do explain some of the differences we see between over and underconsumption, but this also suggests that income is far from explaining all of it. Actually, we can see again that the efficiency of the house, no matter the income, the efficiency of the house is actually impacting the behavior, the way people are using the house. So users are important, I think I have shown now, but how to conceptualize them? I work from a practice theoretical approach. I'm not the only one doing that. Quite a lot of researchers in last 10 to 20 years working on household energy consumption has worked from this approach. Very often we talk about the behavior of people, and there's another type of theory called, for instance, theory of planned behavior. And in this kind of behavioral approach, the idea of understanding the users is to say that, well, users have an intention which lay behind their behavior, and there are some attitudes and norms behind this intention. So people are aware of what they are doing when they do something. In the perspective I work from, the practice theoretical approach, we don't necessarily believe in this idea of the single individual having an intention behind the behavior. We are much more focused on the routinized part. So the things we are doing every day without really thinking about it. And we're also not so focused on how the individual behave. Because basically we think that when we are consuming energy, we do it, all of us, more or less the same. We are heating our homes more or less in the same way. We are taking showers every morning, more or less the same way, all of us, and we are not very intentional or rational thinking, now I want to do this. It's much more something that we routinely continues to do day after day without really thinking about it. And in the practice theory approach, we also focus on how technology and infrastructure are included in forming these practices. As I just showed with the example of the energy efficiency of the house, people are not necessarily intentionally thinking, now I turn up or down the heat because I live in an old or new house, but this is something that happens where the technology or the infrastructure of the house is impacting the way people are behaving. So from this practice theoretical approach, we are also much more interested in how things become normal and how things change over time. So we move the focus from the individual and move it towards the collectiveness of how we all behave in a normal way. So what I wanted to say with this is that I think practices are collective. It's something we do, all of us, all the time, but there is still some socioeconomic variations. And the material possessions, how rich we are, for instance, influence the type of house we have, the insulation of it, and the technologies we have in the house, and the routines and cultures we have in our daily life. We can also see that in a lot of research, that this is something that we carry with us from our childhood. So the way we are educated by our parents can influence the way we are using the house and the way we are heating our house in our adult life. Knowledge and skills also varies between people, between age groups, between what education we have, but also with gender. So there are some variation in the way we are carrying out practices, but basically practices are also the same in all these different groups. I want to show just a quick example of how we can use this. We asked people in a survey some years ago how often they were airing and why they were doing it, and quite a lot of people, almost 40%, said that they were airing after a routine. So it was something they just did habitually at the same time, in the same way, day after day. And for those who kind of not had a fixed routine, it was more kind of related to the practices they were having in the home. So they were airing when they were showering, or when they were cleaning the house, or when they were cooking. So the airing, the opening up the window, was done in relation to the practices they were performing in the house. And we also tried to see how this correlated with the socioeconomic and demographic of people, the age, gender. And actually it did not show a lot of significant correlations. So people more or less all behave in the same way. We would, from an energy perspective, because we know that we need to save energy, and we also know that we need to indoor climate. So it would be really good if we could influence the behaviors, the practices of people in the houses, the way they are opening and closing their windows, and the way they are turning up and down heating. It would be really nice if we could impact that in a way where they both saved energy and had a healthy indoor environment. So an experiment was done in some apartment buildings, social housing apartment buildings, where people, normally you pay for the heat you consume, and that could kind of push people to consume less energy and keeping maybe not a very healthy indoor climate. So in this experiment, people should rather pay for poor indoor climate rather than only for the heating. And poor indoor climate would be based on, there was a cloud-based solution where indoor climate measurements of CO2, temperature and humidity was done on a 5-minute basis all the time to see how are the indoor climate now. And then to prevent people from having it too low temperature, which could give problems of mold, for instance, they should pay according to this. So the measurements would say that if you have high CO2 level in the house, if you have high temperature, or you have high humidity, means that you should pay more. But also if you have too low temperature or too low humidity, and this low humidity was to prevent an overventilation, thus a waste of heat, this would mean more payment. So every month the residents would get an overview of how their indoor climate had been the last month, and then they would get a calculation how much they should pay for this. So if they stayed within a certain temperature level, and I have put up the temperature, humidity and CO2 concentration level here in the table. So if they stayed within these levels of what is considered good, then they would pay less. But if they had too low or too high temperature, they would pay more. So what was the experience with doing this kind of payment among this group of residents? Well, I would say there was mixed experiments. basically there need to be a really good communication to the residents if they should understand that. Many people don't understand these kind of indoor measurements and they didn't really see it. But there was also people who actually found it very interested and started to change their way of heating the homes according to this. We also found that the measurements could be a very good dialogue between the residents and the building managers. So if residents have complaints, that the building managers could look into the data and find ways of having a good dialogue with the residents about it. Some residents understood the system and then it's more easy, of course, to react to the system if you actually understand it, but other residents didn't understand it. Some of them also got really angry with the ideas behind the system. So this is not to say that this was a good solution or something that should go ahead, but it shows some experiences of how the dialogue between residents, technologies, and building managers can help achieving both a good indoor air quality and a reduced energy consumption. So very often when we talk about the problems of saving energy and still having good indoor climate, we hear that smart technology are the solution to what has been called the user problems. In some of our research, we have been interested in how professionals talk about this and how the users tend to talk about it. So when we interview professionals working with developing technologies or managing buildings, we often hear quotes like this: "The less the occupant interfere with regulating, the better. We should automate and control it for them. The more automation, the better comfort and convenience for the user, and ordinary people are not interested and do not understand HVAC technologies." But in the other end, we hear users saying or experiencing that the system has failures and there are problems with interoperability between different types of systems in the same home, in the same building. So the users experience systems that they don't understand, which work counterintuitive according to them. And this also means that users find workarounds if the automation do not work as they prefer. In that sense, the users can always block the ideas of what the designers have thought. So we see some discrepancies between what the professional thinks and what the users thinks. And in the future, I would say this can become even more complicated because the future energy system will rely much more on renewable energy, and this means that flexible demand and load shifting will be increasingly relevant. And buildings, the heating of buildings is also part of that. When still more buildings will be heated by electricity one way or another, they can take part in providing this load shifting and peak shaving of the energy consumption, because you can preheat buildings and then the buildings can keep the heat for a couple of hours. So it's a very efficient way to include the buildings as flexibility generators in the energy system. But again, this will involve even more complexity to the management and the interaction between technologies, buildings, and users. One of my PhD students was focusing on how people engage with smart technologies related to heating their homes, and he developed this figure where you can say you can distinguish between people if they are really engaged with the smart technology or if they really don't care about the smart technology. On the other hand, you can also say some people are really has high ICT information technology competences, and others have really low competences with the smart technology. So this gives us 4 different types of people. Some of them are really nerdy, interested in this and have the competences, and some of them are not at all interested and don't have any competences. And maybe the developers, tech developers, are mostly aware of these 2 types because one of them is, the people who don't care, and the others are the type that look more like themselves. But we also have other types of users. We have the people who actually know about how smart technologies, understand the ideas of the smart technology, but don't want to use their time on it, the no friction household, as he called them. But we also have the people who are really engaged in this, the devoted but limited who doesn't have the ICT competences, but are really engaged and want to understand it. And the technologies we develop to control heating in homes, they actually need to be able, all types of users should be able to use them. If all types of users cannot use them or will use them in different ways, then it won't work. Again, we have some socioeconomics of the smart technology competences and interest. The older generation typically has difficulties in understanding these new technologies, and they will not be as good as the younger generation to understand and use the smart technologies. We also see a gender difference. The most tech interested are really often males. This is not to say that females don't have competences. Of course, there are a lot of females that have the competences. And this is also not to say that all male are tech nerds, which they are definitely not, but the really most interested are often male. And if the smart solution, if the artificial intelligence should be part of the solution in the future, then we need a system that works for all types of users. So what I have tried to say is that users are important. We will not achieve healthy indoor air quality or reduced energy consumption without involving the users. I have also said that technology and behavior cannot be separated. If you change the technology, the behavior will also change. So users are different when it comes to competences and engagement, and we need to understand that. So real knowledge, not assumptions of users, should be included already in the design of the new technologies and the building systems. The project behind many of the results I've presented here is a ERC advanced grant, New Energy Consumer Roles in Smart Technologies, Actors, Practices and Equality, and you can read more about the project on this website. And then I have some references during the slides, which you can see here. Thank you very much.